We are building the Wordle project from the WiByte Python curriculum available at www.wibyte.in. Previously, we saw how we solved the problem of the repeated letters. Quite an interesting, quite an elaborate discussion. However, we also realized that despite our solving it, there was still a problem with this. For example, let's say now chosen word here is shelf. Let's say I choose a word seeks. In fact, we expected both this E as well as this S to become gray because one S is green, one E is green, and the word shelf has only one S and one E. But what we find is that some reason this also becomes yellow. So this kind of misleads us. In fact, we wanted this to become gray. Now we'll see in this video how we'll enhance the logic that we have been developing so far to take care of the situation. Now I want to really emphasize that this is really an enhancement because once we are clear with the logic that we have used so far, which is basically captured in, let's say, this small piece of code here, once we have got clear with this thought process, we'll find that enhancing this to handle this situation is really a very logical progression. So my request to each one of you is that first try to understand that logic, be clear with it, and then you'll find that this logically flows from there. First, let's try to understand what exactly went wrong. Like I said, we expected both E, the first one, and the S, the second one in this case, to become gray, but only E did. This S still remained yellow, and that's really happened because think through the progression of the code. Count is 0 when I first encounter E, M is 1. Well, because there are two E's here, one E here. Count is less than M, and hence I go and change this E to gray. At the same time, I make count equals to count plus 1, so which means count becomes 1. When it comes to this S, that means when count is 1, M is 1. Unfortunately, I will not change it because remember, my logic is to change the color to gray if the count is less than M. Really, the problem came because there are two repeated letters here and the counter started interfering between both of these. Now, this also leads us to a solution. Well, all I need to do is to maintain a separate count for all the yellow letters that I'm seeing. And that's exactly what I'm going to do. So basically, I'm going to use pretty much the same logic, but use a separate counter for each of the letters. Doing so, however, we will convert count to a list and we'll also introduce a new list called RPT letter, kind of like repeat letter. This repeat letter, the list will contain all letters that have seen a yellow, and count will be a list again containing the running count of occurrences of these letters. Really, if you think about it, this is just generalizing the logic, and these two are in perfect sync. Now, with this done, in fact, you will find that the code will just follow logically. Let's do this and we'll understand this better. So I'm going to come in here. Like I said, I'm going to convert my count to a list. I'm just going to leave it to an empty list. And I'm going to create a new list called RPT LTR, which is also an empty list right now. Now, the moment I encounter a yellow, so let me just, comment out this piece of code. We'll not need this because, we are going to sort of enhance this now. So I come and say, okay, look, the moment I see a yellow over here, I ask myself, is this a letter that I have previously seen in the repeat letters list? So I ask myself a question. Well, if it's not, then I need to enhance the repeat letter list and we'll see what that means. So I just say, okay, look, if not guessed, word, say KK in RPT letter. So if this is not the case, which means this is a new letter, I've not seen this as yellow earlier. I am going to say, well, let me append the count to, so append say 0. So I'm creating a counter kind of like for this letter. And I'm going to say RPT LTR dot append, let's say the guessed word KK. Now again, we'll see this code working and we'll take a look at some graphical explanation of why this thing works. But really the logic is going to follow from here. All I'm going to do is that I'm going to find out for that letter the running count, and I'm going to do that because remember my lists are in perfect sync. So I'm going to basically say, well, count repeat letter dot index. So where is this, let's say, letter in this repeat letter list? I'm going to find the index of guessed word KK, and if that is less than M. Now this is interesting. Notice the correspondence, notice similarity. Previously I was just looking at count. Now count is a list, so I'm finding the right item of that list and I'm comparing that to M. If that is less than M, indeed I will do exactly what I was doing earlier. So I'm just going to take these two statements and put them over here. Um, let's say, so I'm going to do exactly, I'm going to put these two statements over here. Also, previously I was increasing count by 1. Over here now, I'll just increase this whole thing by 1. Because remember, this list now must be updated because I have encountered one of this. And I'll do it a little bit more concisely by just saying, well, this is, let's say, plus equal to 1. Now, again, as I always do, first let's see this working, see if this solves the problem, and then we'll try to understand what's going on, because that way it's a bit more clearer. So here I come in, I run my code. I have fixed the chosen word to shelf because I want to repeat this problem again and again. So when I now try, for example, seeks, what I notice is that, notice this is green, this is gray, this is also gray. Now, this is really not surprising because all we have done is to apply the same exact logic separately on E and S. Previously, the two were getting mixed up. Now they're not because of these lists. Let's see how this thing works. Well, basically, when I came in, remember, when I first encountered an E, the list repeat letter was empty, and hence I appended E to this list. So list became E, but my count became 0. At the end of this, right, end of this operation, of course, count was, I'm comparing 1 to say 0 here. This became gray. When it came to S, I found that, well, S is not part of this list. So I went and appended S again. So my repeat letter became E and S. Notice, however, my count has become 1 and 0 because there's been a 0. This is a 0 time the S is being encountered, the first S is being encountered. There has been one E before, which has been captured from here. But the point is, I'm comparing 1 to this 0 now. And that's what is happening because of the indexing. So, I'm comparing 1 to this 0 now, and hence I convert this to gray. Let's just very quickly look at the code to make sure, I understand what we are going. Remember, first thing, if we don't find this in the list, I go and append it. So I put a 0, I add that letter. Once that is appended, I am looking not at count 0, but looking at the right index on the count, which is basically finding out how many of that occurrence of that letter has happened before. I compare that to M, and once I do that, I just increase that same quantity by 1. So it really is the same logic being generalized a little bit, which is why I said this is kind of like an enhancement. Once you understand that, this will kind of follow with a little bit more of lists, let's say, being used. But with this, I think our Wordle game is in a really, really solid shape. This, very nice to solve these problems. Very logically, we have approached it, and I hope you found this interesting. In general, if you think this way of learning is fun for you, you enjoy this, you learn better, look at our website because we have many, many, many such activities like this. Take care. Thank you so much. Bye bye.